Hello grade 10s. So for today's lesson we're going to start with the corrections from exercise 5.6 on page 136. You had to complete number A and number B. So I'll start with A. I've already drawn the question in. So I'll just read the question out before we begin. So it says round your answers off to one decimal place in this exercise. So it starts by saying the Cape Town cable car takes tourists to the top of the Table Mountain. The cable is 1.2 kilometers long, so there's the cable in length, and makes an angle of 40 degrees with the ground, which is obviously going to be the angle of elevation. Okay, it says calculate the height h of the mountain. Okay, so there's nothing really too new here. Okay, we're just trying to find the value for h. So I recommend that you start by taking your highlighter and highlighting the side that they want you to find. And then you notice, okay, well, the side that they want you to find is exactly opposite to the angle that you have. So I'm going to call that opposite. And then, of course, the 1.2 kilometers would be the hypotenuse, seeing that it is the side opposite to the right angle. Okay, so opposite and hypotenuse has everything to do with sine. So I'm going to say sine of 40 degrees is equal to opposite, which is h, over hypotenuse, which is 1.2. Okay, it's important, don't get confused with this h being hypotenuse and this h being height. Okay, they are different, so don't start getting confused now. Okay, so if you want h on its own, you can see that you're dividing by 1.2, which means that on both sides, you're going to have to multiply by 1.2. So you'll have h is equal to 1.2 times sine of 40 degrees. And then you'll put that on your calculator and you'll get 0.77 meters. They said to one decimal place, so that would be 0.8. Okay, don't be intimidated by the small number. Okay, it makes sense because if 1.2 is the hypotenuse, then it would make sense that it would be less than 1 meter. Oh, well, in this case it's kilometer, sorry. So just make sure you check your units. So it's 0.8 kilometers. Okay, then for B, I've also already drawn the diagram. Remember, we said make sure that you have the diagram drawn in your book when you're answering these questions. So it says an architectural design of the front of a house is given below. The length of the house is 10 meters. Then they tell you an exterior staircase leading to the roof forms an angle of elevation of 30. There's the staircase, there's the angle of elevation. The slanted part of the roof must be 7 meters in length. So let's have a look. The first question says calculate the height of the vertical wall DE. Okay, so the first thing that they want is the line DE. So of course it's a vertical wall. It wasn't given in the question, but it is correct to say, well, that must be perpendicular because of course it's a straight wall going from the ground. So in order to find DE, we'll see, okay, but I have 30 degrees over there. Okay, clearly I'm missing some information that I need because you can see that the angle opposite to DE is the 30. So I would call then DE the opposite. I have the hypotenuse and I have the adjacent. So what is given to me is the adjacent, and I want the opposite. So adjacent and opposite is of course going to be tan. So this is number 1. So tan of 30 degrees is equal to opposite, which is what they want us to find, over adjacent, which is 10. Okay, multiply both sides by 10, and you will have DE is equal to 10 tan of 30 degrees. Okay, then if you put that entire thing in your calculator, you will get DE to be equal to 5.8 meters. Okay, remember to leave your answer in decimal form and to also round it off to, in this case, 1 decimal place, because that's what it asked you. Okay, so I'll put that into the diagram just in case. Okay, we might need it. So let's just put it in and then we continue. Okay, number 2, it says calculate the size of theta, the angle of elevation of the top of roof A from the ceiling BCD. Okay, so let's have a look. It says theta, they actually did give it in the diagram, is there. The angle of elevation between BCD. Okay, they want to know theta. So if I look at this triangle here, there's some given information and some information that I can surmise from what I have. So the first thing I know is, okay, well, this is 7 meters because those two sides are equal. That was given. And now they want to know what theta is. So it depends on how you are planning on solving this. Okay, of course, if it's going to be a house, then we also know that this side is 5.8 and the top side here is going to be 10 meters. Okay, so because it was given that this here and this is equal to one another, that means that this perpendicular line becomes a perpendicular bisector. And it's because of the isosceles triangle. So because this is equal to that, if I take then basically this line here, the perpendicular height, is going to be in the center of the base for this larger triangle. Okay, that's just a theory that we would have learned last year when we did geometry. Okay, but just to remind yourself now, which means that this is equal to that in length, which would make this 5 meters each. Now we can see that solving for theta is a bit easier, okay, because we can see theta is here. So if I label this triangle, I can see that this would be the opposite side, the hypotenuse, and the adjacent. So I have the hypotenuse, I just found the adjacent, so I'm going to state, well, adjacent and hypotenuse is cos. Okay, if you would like to also just mention BD is equal to 10 meters and BC is equal to CD, which is equal to 5 meters. Okay, here you can just say properties of a rectangle, and here it's just a perpendicular bisector. Okay, you don't have to go into any further detail with that. Okay, then if we continue, we'll see, okay, we said adjacent and hypotenuse is cos, so cos of theta is adjacent, which is 5 over hypotenuse, which is 7. Now remember, we're trying to solve for theta, which means that the cos is going to go to the other side, which we'll say arc cos or shift cos 5 over 7. So you'll put in your calculator and you'll get 44.4 degrees. Okay. So the next question said, calculate the length of the beam AC. Okay, so it's up to you how you would like to calculate it. You can either use Pythag or you can use the trig ratio that you just found. So if we use Pythag, we would say that AC squared is equal to 7 squared minus 5 squared. So you'll put on your calculator, 7 squared minus 5 squared is 24, and the root of that answer is going to be 4.9. Okay, you can plus minus if you want to, but don't forget that, you know, we don't really talk about negative lengths, so it's acceptable to just leave it like that. Okay, but just make sure that you do give the positive answer there, because obviously a length must be positive. Okay, and then if you wanted to use the trig function, you could say, well, if it's opposite, you can use either sine or you can use tan, it's fine, depending on what you want. So we'd say sine of 44.4 degrees is equal to opposite, which is AC over hypotenuse, which is 7. So AC is equal to 7 sine of 44.4. And you'll see that you get the same answer. Okay, remember you can also do tan if you want, then it would just be opposites over adjacent, so it'll be tan of theta is going to be AC over 5, and then you do the exact same thing. Okay, so you have 3 different ways that you can solve this. As long as you get to 4.9 meters, then you would have done the process correctly. Okay, so that's it for our corrections. So after that, you can rule off. Okay, you can write the date. So the date and the heading. So the heading is going to be the reciprocal functions of the trig ratio of trig ratios. Okay, sorry, my pen seems to be glitching out a little bit. There we go. Okay, so if we'll continue, so today we're going to basically be discussing what reciprocal functions are when it comes to trig. So, first thing is we want to know what is a reciprocal. So, if you can recall from last year, okay, a reciprocal is basically a number that you can multiply with the original in order to give you an answer of 1. So basically the rule states that you take the original number and you multiply that number by the reciprocal of the original number, and you should always get an answer that is 1. Okay, so that is basically what a reciprocal is. It's multiplying the original number by the reciprocal to always get a value of 1. Okay, so let's try an example. So if I ask you the reciprocal of the following, so let's look at the number 3, and then we'll also do 5/7, and then let's maybe do negative half. So remember, the goal is to get 1. So in order to get 1, you multiply 3 by something in order to get the value of 1 now. In order to do that, okay, you can simplify it if you want to. You can do equations. It's really up to you. But at the end of the day, it should be quite easy to tell that it's just going to be 1/3. Okay, if I look at B, 5/7, the thing that you'll multiply it by, the number in order to get 1, is going to be 7/5. And for C, the number that you're going to multiply it by will be negative. 2 negatives make a positive. 2/1, which is just -2. So you may have noticed that there is a little bit of a pattern here. So all you have to do is you just swap the numbers around on a fraction. So if it's a whole number, remember whole numbers are just over 1, so you swap it around to get 1/3. Or in this case, 2/1 would be the reciprocal of a half. So again, in general, we can follow the rule that says if you have A divided by B and you multiply that by B divided by A, you will get 1, where this one is the original and this one would be the reciprocal. So now what we do is we take these reciprocals and we relate them to the trig ratios as well. So if we consider the trig reciprocals, let's look at firstly the original numbers or the original functions. Okay, so the original ones is going to be sine of theta, cos of theta, and tan of theta. So now we know that the reciprocals is obviously going to be 1 over sine of theta, 1 over cos of theta, and 1 over tan of theta. Okay, easy enough to remember that. But now, in order for us to compute this a bit easier, what we do is we give new trig functions to these reciprocals. So the new functions that we relate to for 1 over sine of theta is going to be the function cosecant. So it will be cosecant, but we just call it cosec of theta. Okay, so basically the function cosec is the reciprocal for sine of theta, which is actually 1 over sine of theta. So 1 over sine of theta is equal to cosec theta. Okay, then for cos, we're going to use the reciprocal for cos, which is going to be the second function. But the simplified way of writing it in the equation is going to be sec theta. And then the last one is the cotangent function. Or simplified to cot of theta. Okay, so when we look at the reciprocals, we relate sine of theta having the reciprocal cosec of theta, cos of theta has the reciprocal of sec of theta, and tan of theta is the reciprocal of cot of theta. So we can state that sine of theta times cosec of theta will equal to 1. That cos of theta times sec of theta will be 1, and that tan of theta times cot of theta is also 1. Okay, so how do we relate this now to our ratios? Because remember, we use the trig functions in order to solve for ratios. So if we know that sine of theta is equal to opposite of hypotenuse, cos of theta is adjacent over hypotenuse, and tan of theta is going to be opposite over adjacent, then we can use the rule that we learned earlier about what reciprocals are to find the ratios for those reciprocals. So cosec of theta is going to be the fraction but in opposite, so it'll be hypotenuse over opposite. Sec of theta is hypotenuse over adjacent, and cot of theta is equal to adjacent over opposite. Okay, so all I've done is I've just taken these and I've swapped them around in order to get the ratios for my reciprocal functions. Okay, so of course then this becomes helpful when we need to solve very quickly for something. So remember that we are able to use triangles, we're able to use the regular ratios, so it would work the same for x, y, and r. So it would still be r over y or r over x or x over y. Okay, so remember that it also works in the Cartesian plane as well. Okay, so let's consider the following example. I have this triangle here. I'll call it A, B, C. And then we'll call the little letters A, C, B like that. So if theta is there, I can state, well, sine of theta is equal to opposite, which is C, over hypotenuse, which is B. Then I know that cosec of theta is going to be B over C. Okay, because we'll just swap it around. If I asked you to give me cot of theta, you would say, well, because sine of tan of theta is opposite over adjacent, this one is going to be adjacent over opposite. So I'll say cot of theta is adjacent, which is A, over opposite, which is C. Okay, so just an important thing to remember is that as much as these work for normal triangles, they're also going to work with the special angles as well. Okay, so if you're asked, for example, for a special angle, so let's say cosec of 45 degrees. Okay, it's up to you on the way that you can do it. You can either find sine of 45 degrees and then swap it around, or if you've drawn the triangle, then you can just find the inverse, which is going to be hypotenuse over opposite. So if you go to your triangle, you'll see that it's the triangle that has the root 2 as the hypotenuse. So hypotenuse is square root 2, the opposite is 1, which means the answer is root 2. Okay, important to take note is that these reciprocals are not on the calculator the way that sine, cos and tan are. So if you're computing it, you can compute it on your calculator as 1 over the sine of whatever you're trying to find. But there's no other way to do it. So there's no computing cosec directly onto your calculator the same way that you can compute sine of theta. Okay, but that is essentially everything. Okay, so it's not too tricky. All it is if you can remember what a reciprocal is using this rule here, and stating that, okay, well, if I swap my numbers around on a fraction, then I would have the reciprocals, then it should be quite straightforward to remember these functions here. Okay, something else that I also found to be quite helpful is that if you struggle to remember which one belongs with which, you can also have a look and see, well, sine with an S will relate to the third letter for this function, cosec. So because cosec has S on its third letter, you can remember it as sine. If you go to the third letter in sec, you can see it's a C, which is for cos, and the third letter for cot is tan, so that's just a helpful way to try and remember it, that if you look at the third letters of your reciprocals, you'll find that they match the first letters for the originals numbers that they are reciprocals of. Okay, so this is something that of course you have to know off by heart and very well. Okay, and that will be all. So your homework then for this is going to be exercise 5.10 on page 143 in your textbooks. Okay, I would like you to answer A, and I would like you to also answer C, D, and you can also do E. Okay, so for A you can do the whole thing. For C you can do number 1, number 5, number 8 and number 9. D you can do number 2, number 5 and number 6, and for E you can do the whole thing. Okay, so make sure that you go over this and you practice everything that you need to know, and then in our next lesson I'll go over the corrections and we'll move on. Okay, so this is our last video lesson that'll be on trig. So besides the corrections that I'll do in the next video, this is where trigonometry comes to an end for now, before we look at the graphs later in the term. Okay, so very important to take note then is that our next lesson is going to go back to book 1, where we're going to start with number patterns. So please make sure that you start working out of your book 1s. We'll work out of book 1s for the next 2 weeks or week and a half, and then we'll continue when I get back with those book 1s. Okay, so this is the end of our book 2 for now. Okay, so please make sure that you go over all these notes. Okay, when I get back, very soon after I get back, we're going to do a test on all the trig that we've learned so far. So please just make sure that you're ready for that, because of course the time is going to be very minimal and there isn't going to be enough time for you to go over this stuff at a later stage. Okay, so make sure that you are working through it, and then I'll see you on the next one.